Okay, so since we're done with chapter 3, we're starting with chapter 4, exponential functions. 4.1, it's about exponential functions. Before talking about exponential functions, let me give you a quick review or a quick reminding of what are exponents or powers. What do we mean by powers or exponents before moving to exponential functions? Well, if you have got b, okay, where b is any number, and if you have got b to the power of n, okay, that n is a power, is an exponent for that number b. If you have got that n is a positive integer, that means a positive number, okay, a positive integer, that means, for example, 1, 2, 3, 4, and so on. So what will we have? That means b is multiplied to itself n times, okay? It is multiplied to itself, that means n times. For example, if you have got 3 to the power of 2, what does that mean? That 2 is the exponent, okay, or the power of 3. That means 3 is multiplied to itself 2 times. Well, you know that result. If you have got, for example, 4 to the power of, for example, 5, that's an exponent for the 4 or the power of 4. That means 4 is multiplied to itself 5 times, okay? 1, 2, 3, 4, 5. Okay. That is a positive integer exponent. How about if you have got a fractional power? That's a positive integer power. Here, that n is a positive integer power. Okay. How about if you have got n, okay, as a fractional, so fractional power. What do we mean by that? For example, if you have got b to the power of n over m, okay, that's a fraction. How do I represent this one? I can write this one as b to the power of n all under the mth root, or I can say that this is b, okay, under the mth root with the power of n. When I say b to the power of n over m, I mean that this n is the power, it's always true, okay, and that m is the root for that b. Okay, so we have got the n, the numerator is power for the b, for the number that I have got, okay, and that m, the denominator is always the root for that function. For example, if I have got 2 to the power of 1 over 2, what does that mean? That means 2 under the square root. How about if I have got, for example, 3 to the power of 4 over 5? What does that mean? That means 3 to the power of 4, that's the power, all under the fifth root. Or I can write it as this way: 3 under the fifth root, all to the power of 4. Okay, either of the cases are true to write because it represents both of them. Okay, that is for fractional powers. How about if I have got, let me write this one as it is, and that one as a point. And here, if I have got a negative power, where n, okay, is a negative power. How can I represent this one, or how can I say that this one is working? This works as b, for example, to the power of minus n. Whenever I have got negative power, the b will become upside down with the same power, okay? So that will be 1 over b all to the power of n. For example, if I have got 3 to the power, or 2 to the power of minus 3, how can I write this one? Since I have got a negative power here, so the 2 goes down, okay, it becomes 2 to the power of 3. Look, the 3 is the same, the negative makes it upside down. Or for example, if I have got for example, 3 to the power of minus 5, how can I write this one? Since I have got a negative power, so that will be 3 to the power of 5 in the denominator. Or if I have got, for example, 1 over 4 to the power of, say, minus 2. Okay, what does that mean? Since I have got a negative power here, like this one is working, it brings it down the denominator. If it is in the denominator, I can take it to the numerator. So that will be 4 to the power of 2. Okay. Okay, so that's for powers. And of course, if I have got a 0 power, shall I write somewhere here? Okay, I'll write it here. If I have got 0 power, how can I represent it? If n is equal to 0, where that means b to the power of 0 is equal to 1 always. Okay, so if I have got, for example, 2 to the power of 0, that's equal to 1. If I have got 3 to the power of 0, that's equal to 1, or whatever to the power of 0. When I have got it, it is equal to 1. Okay, of course, the b that we are talking about in here is a positive number. Okay, it's not any other number. That's about exponents and powers. Now we are moving to exponential functions. What are exponential functions? When we are talking about exponential functions, it is a function. Okay, here we were talking about exponents and powers, but here we are talking about functions. So it has got functional values, it has got functional rules, properties, it has got those properties. But these ones that we explained here, exponents and powers, it was just a number to the power of something, a number with an exponent. Okay, it was not a function, we were just calculating it, didn't have any thing like a function. So let's move to the exponential functions. Let's give the definition. Okay, exponential functions. Okay, what do we have? We say that if b is a positive, let me write it, it's a positive number other than 1. So I have got what? Writing it simply, b is greater than 0. It's a positive number. And of course, b is not equal to 1 because it says other than 1. Okay, so b is greater than 0 and also b is not equal to 1. There exists a unique function. Okay, there exists a unique function. How can we represent that function, that unique function? And what is it called? It is called an exponential function with base b. What is the base of that exponential function that I am talking about? It's the base b. What is that b? What are the conditions on that b? The b must be something greater than 0 and not equal to 1. Okay, such that, or defined by, okay, how is that exponential defined? As f of x is equal to b to the power of x. Of course, for every real number x. What does that mean for every real number x? That means that x is taking any value in the real numbers, positives, negatives, 0, it doesn't make a difference, rationals, irrationals, it is taking every number that we have got. Okay, so let's come to the general idea of an exponential function. In previous explanation, what did we have? We had b to the power of a number. Okay, but here we have got to the power of x. So that's a function we are talking about. What are the conditions on that function? We have got that b. Okay, let us write it simply. Here is the function that I am working on. Okay, that I am calling it an exponential function. That b that we have got, what are the conditions on it? B must be greater than 0 and that b must not equal to 1. Okay, so if that b is a negative number, we cannot say that that's an exponential function, and if that b is equal to 1, we cannot also again say That is an exponential function, okay? And what is that x? That x is an element in the real numbers, okay? So what are the conditions? What is the domain of that function? The domain of that function is all real numbers, and the range of that function, since the b is a positive number, the range, okay, is from oh sorry, 0 is not included, from 0 to positive infinity. Okay, how is the graph of that function? When we are talking about the graph of that function, of course, when we are talking about graphs, we have got what? X coordinate and Y coordinate. Okay, we are simply drawing a function in X and Y coordinate. It is a function that's passing through 1. Okay, and continues for going on like that. Okay, it is approaching to x-axis. Okay, that's x-axis, and that's of course y-axis. That is an exponential function, b to the power of x, where that b is greater than 1. Okay, so if you have got 1.1 to the power of x, it is like that. If you have got, for example, 2 to the power of x, it's rising a little bit more, 3 to the power of x coming here, 10 to the power of x, and so on. And the graph of that function is like that. Okay, the opposite to that one, it is like that. That's also b to the power of x, an exponential function. If that b that we have got here is between 0 and 1. Okay, so that's the graph of an exponential function. We said, what's that point? That point is when x-axis is equal to 0 and y-axis is equal to 1. So it's always intersecting y-axis at point 1. Okay, let me do a bunch of exponential functions together. Okay, that's page number 16. For example, if you have got for example, if you've got 2 to the power of x, it's something like that. Okay, if you have got 3 to the power of x, let me draw it here. It is like that. Okay, if you've got, sorry, that one has gone wrong a little bit. If you've got 10 to the power of x, it is rising a little bit more. So that's 10 to the power of x, 3 to the power of x. We have got this one is 2 to the power of x. Why the graph of the function is on that side? Because we said if the b, the base of the function, is greater than 1, the graph of the function is like that, is on that side of the y-axis. How about if the b is between 0 and 1? So it will be like that. For example, if you have got, sorry for that, that is, if you can see from here, that's 1/2 to the power of x. Okay, 1/2 is between 0 and 1. So the graph is like 2 to the power of x, but on the opposite side. If you have got 1/3 to the power of x, sorry, the graphs are not so accurate. Okay, that's 1/3. What is 1/3? It is a number between 0 and 1, so that will lie on the opposite side of 3 to the power of x. If you have got 1/10 to the power of x, so the graph of it is something like that. Okay, that's 1/10 to the power of x. So the graph of 1/10 to the power of x is the same thing, or the reflection of 10 to the power of x about y-axis. But since 1/10 is between 0 and 1, okay, so it is lying on the other side of the function. Okay, generally talking generally talking about the properties of exponential functions, we can say in general An exponential function is a continuous function. Look, if you look at, you've already studied the continuity of a function and you know what a continuous function is and how does it look like. If you look at the graph of each of these ones, if you look at it, it looks like the function is continuous, okay? So the function f is continuous, okay? Then what do we have? The x-axis, if you look, the function is never, well, here it has touched it because the graphs are not so accurate. But in general, when we are talking about exponential functions, x-axis is a horizontal asymptote, okay? It's a horizontal asymptote for the graph of the function, okay? These ones or those ones. If you look at the function here, whenever, wherever, whichever function, an exponential function we drew on that xy coordinate, we got that the intersection point is that point which is 0 and 1. So if you look at it, the y-intercept, okay, if you remember, the y-intercept is the intersection of the graph of the function with the y-axis. The y-intercept is equal to what? Is equal to 1, okay? Of course, there is no x-interception because the graphs of the function do not intersect with the x-axis. The fourth thing, if b is greater than 1, look, if the b, the base of the function is greater than 1, like 1.1, 1.5, 2, 3, 4, 5, 5.5, 10, 10.5, or whatever, when the base is greater than 1, the exponential function is what? Is increasing, okay? Is increasing. And if b is between 1 and 0, f is decreasing. Look at the graph of the function. When the numbers, the bases are between 0 and 1, the function is decreasing. That's the general idea about exponential functions. We know that we have got a base for an exponential function. That base that we're talking about must be something that is greater than 0. That means a positive number and must not equal to 1. The domain of the function is the set of all real numbers because the x that we have got here takes every number, positives and negatives, zeros, rationals, irrationals. The range of that function, that means the output of that function, is between 0 and positive infinity. We know that the graphs of the function is like that. We know that the function is always continuous. We have got the horizontal asymptote for that function and so on. Of course, that exponential function, if you have got 2 to the power of x, it's different from x to the power of 2, okay? Here the base is a number, here the base is an x that we have got. That's a power function. That one is an exponential function, okay? That one is exponential function. That one is a power function. Of course, the graph of this one is parabola faced up, but the graph of this one is just like that. So there is a difference. Of course, there are lots of difference between them. Now we are coming to the exponential rules. What are the exponential rules? Exponential rules. Let's give the first rule of exponentials, okay? And you're already familiar with those rules that I will be talking about. The first rule that we have got is called equality rule. What does that mean, equality rule? That means if I have got b to the power of x and that's equal to b to the power of y, that's true if and only if the powers are the same, okay? That means if and only if. Why is that? For example, if I have got 3 to the power of x, that's equal to 3 to the power of, for example, 5. Okay, now look, the bases are equal, so I must definitely have that x must equal to that 5. Okay, x is equal to 5. Of course, if that x is not 5, I will not have that equality here. It will be something else between them. Okay, the second rule, what is it? It is the product rule. What is product rule? B to the power of x multiplied to b to the power of y. Look, I have got multiplication between this one and that one. The bases are equal and the powers will add. So that will be b to the power of x plus y. Let's give an example about that. For example, if I have got 3 to the power of x multiplied with 3 to the power of 5. I'm giving the same example so that you see the difference between them, so that you can compare them. What is the difference between them and that one? Okay, since I have got these two exponential functions multiplied together, okay, and the bases are equal to each other, so that's like 3 to the power of x plus 5. Okay, the third rule that we have got is the quotient rule. If I have got b to the power of x divided by b to the power of y, so that will be b to the power of x minus y. Look, multiplication changed to addition, and quotient division changed to subtraction. So what does that mean? If I have got 3 to the power of x over 3 to the power of 5, that will definitely equal to what? 3 to the power of x minus 5. Okay, okay, uh, we've got power rule. The fourth rule that we have got is power rule. We have got b to the power of x all to the power of y. What does that equal to? That will equal to b to the power of x multiplied to y. Okay, here multiplication changed to addition, quotient changed to subtraction, and this power changed to multiplication. Okay, what do we have here? Sorry, 3 to the power of x, for example, all to the power of 5. What does that mean? Since that's a power rule, so I will have this one is 3 to the power of x multiplied to 5. So that one is equal to what? 3 to the power of 5x. And next we have got multiplication rule. Okay, that was product rule. Now I have got multiplication rule. What's multiplication rule? I have got AB, okay, all to the power of x. A base is multiplied with another base and all to the power of x. So that power is for both of them. That will be a to the power of x, b to the power of x. So in general, for example, if I have got 3x to the power of 5, how can I deal with this one? 3 is multiplied to x. Look, two different bases. So that will be 3 to the power of 5, x to the power of 5. The sixth rule is the division rule. If I have got a divided by b all to the power of x, so the x is again for both of them, a to the power of x, b to the power of x. So if I have got 3 over x, for example, all to the power of 5, that 5 becomes the power for both of them. Okay, of course these rules are important when you are having exponential equations, logarithmic equations that later on we will have them. You have to know those rules. You have to know how to use them throughout the materials that you have got, throughout the examples that will be given to you. We have got example 4.14.2. That's very easy example. I will leave it for you because it's just the calculation of 3 to the power of 2 multiplied to 3 to the power of 3. That ones are easy. I will move to example 4.1.3. Okay, because in that example we are using the exponential rules to solve an exponential equation. That's page number 18. Okay, example 4.1.3. It says if f of x is equal to 5x to the power of 2 plus 2x, find all values of x, all, let me write it all, find all values of x such that f of x is equal to 125. Okay, so what do we have? We are given a function f of x that's equal to 5 to the power of x squared plus 2x. And we are given again the function is equal to 125. What's required from you? To find those x's that are given in here. So since I know that f of x is equal to this and f of x is equal to that, so what shall I do? F of x is equal to f of x, so 125 is equal to 5 to the power of x squared plus 2x. Okay, why? Because f of x is equal to 125 and the same function is equal to this one, so those two values are equal to each other, so those two functions are equal to each other. Now what's required from us? It's required from us to find those values of x. How can we find those values of x? Using the exponential rules. How do we use them? Of course, if two things are equal to each other from the exponential rules, okay, if two things are equal to each other, either their bases are equal to each other or their y's, I mean the exponents. Here, if you look at here, we have got 125. Can we change 125 to something with a base of 5? Definitely we can change it, because we know that 125 is 5 to the power of 3. And I will leave this one as it is. I will not make any change in that one. Now, if you look at here from the first rule of exponentials, we have got if two things are equal to each other and the bases are the same, so the powers must definitely equal to each other. So 3 is equal to x squared plus 2x, okay? Since the powers, I mean the bases are equal to each other, so the powers must equal to each other. If you look at this one, that's a quadratic equation. I will rearrange it. That will be x squared plus 2x, and I will take that 3 to the other side. Minus 3 is equal to 0, okay? That's 0 here. Now from here, what can I do? I can change this one into two brackets. That's equal to 0. I will write an x here, an x there. For 3, I have got 3 and 1. Which one is positive? Which one is negative? Let's set this one as positive, that one is negative. Why? Because when I multiply plus 3 with minus 1, I will get negative 3, and when I will add them, I will get plus 2 here. So I've got the product of two parentheses that's equal to 0. So either x plus 3 is equal to 0 or x minus 1 is equal to 0. So x is equal to, that's a linear equation, x is equal to 3 by taking this one to the other side, okay, or x is equal to 1. So what did we find? We found the values of x's that were required from us. So either x is equal to minus 3. What does that mean? That means if I put instead of those x's minus 3, I will get the result is equal to 125. Or if I put x is equal to 1, that means instead of x squared, I put 1 squared plus 2 multiplied to 1, I will again get 125. And that are the x's that were required from us. Okay, that was an exponential function. We have got something else, it's called natural exponential function. Okay, let me write it. Natural exponential function. What's natural exponential function? We know what is an exponential function. We said an exponential function is a function. Let me go back to the other papers. It's a function with a base b, that b is greater than 0, not equal to 1. The x here takes all real numbers. So what is a natural exponential function? A natural exponential function is a special case of an exponential function. Why is it special? Because the base of that function is something special. We know that we have got a number e in mathematics. That's a special number, okay? E is a special number. You know that, okay? If that e is the base of the exponential function, we call that exponential function b to the power of x, okay? If I change it to e to the power of x, that's called what? Natural exponential function. Okay, I've just given a name to that one. It's still an exponential function. It still has got the properties of exponential function. It is continuous. It is intercepting the y-axis from 0, 1. X-axis, sorry, x-axis is a horizontal asymptote for that function. It has got all the properties of this exponential function, okay? If that e is greater than, since it is greater than 1, so it is increasing. If it is 1 over e, it is decreasing. So it has got all the properties of exponential function. It's just something special, okay? Just a special base for that. How is the graph of an exponential function e? Since e is a number that's between 2 and 3, so the graph of it will lie here, okay? So that one will be the graph of e to the power of x. It is between 2 and 3 because the number e is 2.7. That is between 2 and 3. Okay, you do not need to know where has this e come from which limit, from which part, because you're not mathematics students. Okay. And of course, when we are talking about those properties, okay, if you have got e to the power of x equal to e to the power of y, x must equal to y. These ones all hold for exponential functions, except in the natural exponential function, we have got that base is equal to e, okay, or everything is the same. It's just a special case of exponential functions. Okay, that's all about section 1 of chapter 4. It's about exponential functions and natural exponential functions. Hope you will understand the subject easily. Have a nice time, have a good time, and bye bye for this section.